Okay, before we get into the Arduino script with the ESP32 or the ESP8266 connecting to AWS IoT Core via HTTPS, I wanted to make a quick note, especially for those who have already taken this course and are reviewing materials, about why I moved the Node-RED section to the back of the course. Two reasons. First of all, Node-RED now requires a credit card sign up, and other than the free trial of AWS, most students don't want to use a credit card for anything. Now, IBM still says Node-RED's free for limited usage, but I just don't want to use a tool that people may have unexpected charges for. If you still want to use Node-RED, you can get it under the standard plan. And I have those lectures at the back of the course, and they're worth reviewing, but now since I made this course and originally had Node-RED, there's probably 3 times as many videos on Node-RED for IoT and maybe even connecting to AWS on YouTube. So the videos really aren't as valuable as they once were. Now, the second reason is I've just developed a new script to connect via HTTPS to AWS IoT Core. And that was the main purpose I was using Node-RED for. So you could send Node-RED HTTP from your device unverified. It get authenticated in the cloud, and then Node-RED would forward it to AWS IoT Core. That's no longer needed. With the next lecture, you can see we can send our data directly from your device to AWS IoT Core, and there's no need to use Node-RED. But again, if you want to enhance your data, or you want to have multiple data sources or do a bunch of tricky stuff or complex stuff, Node-RED is still a very good tool for IoT in general. So anyways, let's move on to the sketch. Okay, as promised, I want to present to you a sketch showing how to connect to AWS IoT Core using the HTTPS certificate secured communication method. Now, normally you're going to want to stick with MQTT, but there are certain exceptions where you may want to use HTTPS to communicate to AWS IoT Core. The primary reason would be if your device doesn't have MQTT available, either supported by device or there's not a pub/sub library available or one you want to use. Now, generally HTTP is better for large payloads set up less frequently. There's an inherent problem which makes it not so good for IoT. It doesn't natively provide duplex communication like we had in MQTT, where you can both publish and subscribe and get messages both ways. So we have the publish function covered through HTTP by posting, but we don't have the subscribe function from the device covered by HTTP. So we couldn't receive communications back from the server except with a static web address, which we don't have. And normally you don't get that unless you're serving a web page or you paid for that through your ISP provider. Now, there's a myth that MQTT is a lighter weight protocol than HTTP. It's really not. They both take about the same space in memory and the same time to set up for every cycle. But the advantage of MQTT, again, is a duplex communication. Once you secure the connection, you can send messages both ways without having to reinitiate the protocol. As you'll see when we loop through this sketch, the protocol is going to get destroyed each time. So we have to reestablish the connection for each loop. Now, if you did have really large payloads you wanted to send to AWS, I'd recommend sending it via HTTP through API Gateway and then to Lambda. And then from Lambda, of course, you can distribute that anywhere in AWS Cloud as you'd like. I'm not going to talk about here because it's beyond the scope of the course, and I cover that completely in my serverless AWS IoT course, which is also offered here. But in the resource section, I'll link to that so you can see that article and see that sketch if you want to send on your own to API Gateway and Lambda. Okay, so let's talk about this sketch right now. And you can kind of think about this sketch as divided into 2 parts. There's all the security requirements, and those are identical to the MQTT sketch, so I'm not going to talk about those. So the difference would be if you're using the board manager on the ESP8266 version 2.7 per se, you do the certificates a little different than if you're using 3.0 or above, at least on the ESP8266. If you're using the ESP32, how you set and anchor those bare SSL certificates is the exact same way you would do it no matter what board manager version you were using for the ESP32. So I won't talk about the certificate stuff, but let's talk about what we need to set up specifically different than the previous Arduino sketch where we used MQTT and now we're using HTTPS. So we still have to put in our network ID and password, but we're going to put our host over here. This is our AWS IoT Core endpoint. You can go into AWS IoT Core on the console and go to settings to get this, or you can go to the AWS CLI and put an AWS IoT describe endpoint, and your primary region endpoint will come up. And remember, it's region specific. So make sure you put this in the region where your console is located and you're going to use that test MQT client. And remember also that this client certificate and your private key, they're region specific. They're tied to your region, whereas the root CA isn't. So if you created and activated these certificates in one region, you can't use them in another region. Although the root CA X509 certificate, that one's fungible between regions. For this, we're going to be using point 8443. Remember that MQTT unsecured is 1883, MQTT secured, the convention is 8883, and for just HTTPS secured, it's 443. But Amazon specifically uses their own custom port, which is 8443, kind of a combination of both, so it makes sense to talk to AWS IoT Core. And then finally, we need our extension on our URL, which is called the URI. So we need our endpoint, and then by using this, we're going to add on to it topics. This is a macro that's required. And then I'm using out topic, but this is whatever you want to call your topic. I'm calling it out topic because it's coming out from our device just when we published out from our device, just to keep it consistent with the MQTT sketch that we previously did. And we're going to use the quality of service equals 1. I believe it'll work with 0 too, but keep it as QoS 1. So let's get into the part that counts, and it's the loop part. So it's from here to here that's all new. So let's talk about that. We're going to connect here, and the server's not going to talk back to us like a normal web server. The AWS IoT Core broker doesn't give us any kind of a response. We're going to fill up our fake data in the char buffer here and send it out just like we did. You can alter this, and technically we're not limited to 256 or whatever you set that max message size when we use the pub sub library. Since we're using HTTP, you should be able to set your buffer to something pretty big. So if you wanted to extend this to have a lot more variables, you can go ahead and do that. Okay, finally, and this is kind of the important part that took me a long while to construct, you have to be very explicit in exactly the HTTP string we're sending to AWS IoT Core. If we don't space and format everything exactly correctly, it's not going to work. That's why this part's kind of meticulous to construct, but you can keep it this way, and you can see how I constructed it here. We post this original string, which is just this small buffer here, send it out to our host, signify that we're sending it as JSON instead of text or something else, and then we got to say, hey, how long is our data payload coming in? And then we send our payload, and then two things I add specifically is I had to add this my client stop. And the reason was on the ESP32, there's no garbage collection, which of course we expect in C and C++, but the compiler didn't optimize the binary to destroy the memory stack for each loop. So what was happening is this object kept getting bigger and bigger until it didn't work. And that happened after like 2 or 3 cycles. For whatever reason, I think the optimization algorithm in the compiler may have been better for the ESP8266. Because this was not a problem with the ESP8266, but I had to add this for the ESP32 because that heap size was blowing up. So I just added it to the ESP8266 because there's no downside to doing that. So I just wanted to explain why I had to add that Wi-Fi client object stop. So that's basically it. You can run that, and it's going to look on the cloud side when you connect this to AWS IoT Core exactly the same. Now, obviously, the AWS IoT Core client broker's agnostic as far as where this data is coming from. Anyways, if you have any questions about that, let me know. I'm going to link to my GitHub, so you'll have an ESP8266 version for if you're using Board Manager 3.0 or above, or if you're using a Board Manager below 3.0. Now, again, for the ESP32, it doesn't make any difference how we set those client certificates. All right, so I hope that was helpful and you can play around with this script as well. But mainly, as I said, you're going to want to stick with that MQTT script because it's more common in its usage.